So I will tell you about my background for a second. I used to be a translator. In fact, at the previous UTICamp 2016, I actually presented my translation project. But since then, I went on to be a software developer and learned programming, and I worked in data science. And now I am kind of back in translation industry, but this time I started my own company. And we work for translation vendors to create maybe custom solutions for their clients. We develop plugins. We also work with natural language processing and computational linguistics and stuff like that. And so, because for the past year I've been thinking about technologies as they relate to translation, I've been thinking a lot about, okay, as a translator, what would be an algorithm? What would be the technology that would help me translate better? And so I remember when I was working as a translator, my favorite piece of technology in translation was translation memory matching, because it was super useful, right? Like if you already have something translated, it will just show something similar translated. It will just show you the translation and you don't have to worry about it. And from the point of view of computational linguistics, this algorithm is called added distance. And it's super simple. It just basically takes two strings and it looks, okay, it doesn't use any machine learning. It just takes two strings and looks at, okay, if the characters in the same position are the same, right? And so if all of the characters in two strings are the same, the added distance is 0, but then the translation memory matching is 100%, right? So I've been thinking a lot about, okay, how can we take this concept and make it easier for translators, make it more efficient, make it easier for translators. So I was thinking, okay, maybe I can work with some synonyms, antonyms. Maybe I can pull different phrases from different sentences and kind of put them together. Just any way I can use translation memory to help a translator. And so I noticed a very funny thing is that every time I would think about it, at the end, I would come up with some sort of a statistical machine translation thing, right? Because what statistical machine translation does, it just kind of aligns phrases and words, the translations, and then it has like a little machine learning algorithm that aligns those phrases according to the language. And so that made me realize a very important thing, that the future of translation industry is neural machine translation, because neural machine translation is always better than statistical machine translation. And in whatever way I try to apply technology to translation, I always end up with machine translation, right? But this was kind of surprising to me, because when I was a translator, I didn't like post-editing. It didn't save me time. I had to rewrite the whole sentence from the beginning. It was always a pain. And I'm not the only one who thinks that way. So I am noticing a lot of comments from different translators saying, well, I used to make 15 cents per word, and now I'm always offered 3 cents per word because it's post-editing and it's supposed to make me less time. And it's not an isolated incident, because everybody's talking about this. But I actually, so like it looks like translators are making less and less money, right? But I actually think it's a good thing. I think it means that the world is becoming international and we are having more content to translate, but not everybody is Microsoft or Google. Not everybody has the money to pay you 15 cents per word. So that's why the rates are going down. We just have more work now. So I've been thinking about, okay, what are the ways that we can improve our neural machine translation experience for translators? And I have 4 things to talk about to you today. So first of all, any machine learning algorithm needs lots of data, so we need to add more data to our NMT. We can also adapt it to our wording style and our domain. I will talk about that. We also should be updating our MMT engines constantly. And the last one, the most controversial one, I think we should shift the way we own data in our industry, and I will talk about that at the end. So let's talk about how the translation process is kind of seen in data science. And I like to give this example. This is an information transfer model created by proposed by Shannon. So Shannon is the creator of informational theory. And he said, well, okay, if you want to transfer information between like 2 computers or whatever, first of all, we have to take our information. We have to encode it so the transmitter, Yeah, so the transmitter encodes the information, then it sends it over some channel, and the receiver receives the information and decodes it based on like whatever is the decoding system in its brain, let's say. So if a computer encodes information into ones and zeros, I encode information into words, and I send it to you, and you kind of decode my words into information in your head. And the cool thing about information theory is that when information passes through this channel, there's always some noise. And when it's about computers, it's just that by the laws of physics, the receiver will not receive a message that is 100% the same as it was sent. And in communication, you are not going to understand what I'm saying 100% just because your brain is different from mine, right? And in machine translation, this is why we need post-editing, right? Because the translated string will never be exactly the same as it was intended. And now if you look at a neural machine translation model, this is my favorite illustration of how neural machine translation works. And it's actually a video. Yes, it's playing. So the way we look at neural machine translation in data science is that we have an encoder, and the encoder is the source language model, is the language model for the source language. And we have the decoder, so the target language model. And then we have some connection. We have that transmission channel in which kind of connects, oops, those two models for source and target language. And now I have to explain to you very, very briefly what is a language model in data science and machine learning. And for that, I use this chart. So this is a semantic model, actually. So it's simpler than language model. And it's built by this tool called Word2Vec. So Word2Vec, what it does, it basically converts words into vectors so that computers can understand words. And it does it by taking, like, you feed it a huge corpus of human-created texts, and it looks at all of the words in that text, and it looks at the context. So it will look at like 5 words before the word and then 5 words after the word. And it will look at all of the context as it appears in, and it will do some complicated math that I will not explain to you right now because we don't have time. But at the end, you will have a vector, and the vector will actually represent the semantic meaning of the word. And so when you take the vectors for each word, and you can actually map them onto like a space, and here we map them onto a two-dimensional space. Actually, I think it's like a 3-dimensional space, maybe. Anyway, you will see that the words that have similar semantic information, similar semantic meaning, will appear close to each other. So for instance, like here you have digital devices, computer, Apple. So they are all related. And we didn't explain this to the algorithm, it just learned it by itself. You have, what else? You have international, EU, you have company, corporation are close together, right? Cancer treatment, etc. So, but this is only semantics. But a language model, it learns not only about semantics, it also learns about syntactic information, morphological, like just everything that is about discourse, everything that is all the information encoded in language. And so we can't even represent a language model in this way because it would be so complex that we can't even like imagine how it would look like. So, but from like science point of view, a language model is just a huge file, and it contains a lot of numbers. And the numbers represent relations and distances between words like this. But visually, we represent a language model just by like a black box that we kind of imagine that it encodes and decodes, right? Like, just like this. That's usually what we do when we deal with data science. We just say, oh, it just does something and it's good. But in order to create something like this, something that understands language on a like computer level, we need a lot of data, and we need a lot of good quality, clean data. And I will tell you why by this example. So, not so long ago, this is an example of machine translation developed by Facebook. So BuzzFeed, they posted something about Justin Bieber and that he got a tattoo, and someone translated it using Facebook machine translation, and the machine translation into Ukrainian, and the machine translation used Suzyk. And if you don't know what Suzyk is, I will explain. It's kind of a patois. It's kind of a mixture of Ukrainian and Russian languages, and it's usually used for comedic effect, especially on Facebook. So there are a lot of comics on Facebook that got popular by making these funny posts in kind of a mixture of Ukrainian and Russian language. And what Facebook did, they just took Ukrainian posts and they trained a language model And the language model produced Surjik because it was trained on Surjik. Let me take a breather. So if we want our machine translation to create output better language, we have to train it on good language. And good language, good quality language that was reviewed and edited is rare. In data science, is pretty rare. Second, if we want the translation to be nuanced and good, and represent like actual semantic relations between the two languages, we need to have bilingual data. Bilingual data looks like this. So you have a phrase, or usually it's a sentence. You have a human created sentence, and then you have a human translated same sentence in a different language, right? So that's called bilingual data, and that is our data set. Usually it should be like a couple of million of sentences. And then you kind of feed it to an algorithm that will create your machine translation engine. And that kind of data is super hard and expensive to procure in data science. So when somebody does like academic research on machine translation, they have to pay a lot of money to get data like that. But good news is that that is actually a translation memory, and we work with it every day. And if you're a vendor, you probably are sitting on lots and lots of really good, expensive data. You just can't share it because it's under NDA or any other like legal reasons, which is really sad to me. It's sad to me because one of the like fundamental things about data science that we have realized in the past 10 years is that a lot of data is really, really important in data science. So there's this really canonical popular article in data science. It's called The Unreasonable Effectiveness of Data. And you can go and read it. It's not super technical, and it's mostly about NLP, natural language processing. It's mostly about languages. And it says, well, hey, language is really complicated and kind of unpredictable. And we've been developing all of these really intricate algorithms. We've been doing a lot of math, we've been thinking a lot, but it turns out that and they kind of underperform. But it turns out if you take a simpler algorithm and you feed it a lot of data, it will immediately perform better than the really complicated algorithm. So if you want to achieve better accuracy in machine translation, we just need to feed it more data. And so this article and just this notion in data science, it produced this phenomenon, not phenomenon, but this the phenomenon of data silos. And data silos usually are now used in like a pejorative sense, because it means that, like a negative sense. It means that some big players in some industry, they hold a lot of data. And so let's say we have like four big players in some industry, and they all want like the same output. They all want AI to help them do something with their business, and they all want the same help, right? And so they each have some data, but it's not enough to produce good results. And they will all train the same algorithm, so they will have 4 different models, and 4 different models will underperform. And the fun thing is that if they just came together and put them all together, if they shared the data, they would and created one model, they would immediately get much better results. So they're kind of shooting themselves in the foot by competing with each other, because they could just play the zero-sum game where they share the data, but they also all get the help from the machine learning model that they need. And so I personally think that we should find a way in our industry to somehow share our translation memories so that we could train one big empty engine that will help all of us translate better. And yes, there are legal reasons, and I'm just really tired of talking about that. I think we should somehow get over ourselves and come up with a way where we can share our data. Okay, the second point that I wanted to talk about is machine translation engine tuning. This is really cool. This is something that we are developing right now on my team. So basically what it means, I'm not going to dwell on it, but just to explain to you shortly, you can take a trained machine translation engine, so just a file that already contains all of the information about the language, and you can, or like 2 languages because it's machine translation, you can kind of unpack it, and you can take a smaller data set. So you can take a smaller translation memory. That is, for instance, this project's or this client's translation memory. Or you can take your personal, if you're a translator, you can take your personal translations that you did, and you can plug it in like at the very end of the neural network. And you can plug it in, this smaller data set, and you can tune that engine to your personal data. And what this will do, it will encourage the engine to be biased towards that smaller data set. So it will basically favor, when it produces output, it will favor your wording, and it will favor sentence structures that you do, or like the words that this client wants to use, because they were in this smaller data set of translation memories. And so I think that once this is done, so this is already being done, but I think once we start actually using it, it will drastically improve post-editing time, because you will just need less to post-edit, because the engine is now adapting to the way you do translations. But that still doesn't solve a really fundamental machine translation problem, which I will illustrate with the next slide. So maybe you remember this tweet. If you don't know, a couple of years ago, Trump decided to tweet something, but I don't know, something happened. He didn't finish the sentence, and it produced this word. How do you think it's pronounced? I don't know, kofefe? Anyway. But it has become a meme. It has become a part of our pop culture. And so we use it, and I see it being used a lot, especially when related to like free speech and stuff like that. And I don't know, so if you ask me as a linguist, I think it's a new word in English language. I don't know what part of speech is. I don't know what it actually means. What is the definition? But we use it as a word. But if I, for instance, and it has been existing in our language, or in English language, for 2 years. But if I type it into my phone, my autocorrect will correct it to coffee or something. So it means that we have not updated our language models in our technology for at least 2 years, because computers still don't know about Trump and this word. And that brings up a very important topic, the problem of language as a system in its synchronic and diachronic dimensions. So if you studied linguistics, you know about Ferdinand de Saussure. So Ferdinand de Saussure, he was the first one to propose that, hey, maybe we shouldn't see language as some mystical, magical thing that we don't understand, and it's only like the writers know how to work with it. Maybe we can view language as a system, right? So language is like, we have words, and then we have rules, and so we build sentences according to rules and using these words, so it's a system, right? But he said, okay, but there is a problem, because we can study language synchronically and diachronically. And when we say synchronically, it's kind of like we take a slice. So all of these like kind of squiggly lines represent systems of each language. And so if we take a slice or a snapshot of the world at one particular moment in time, we would have a synchronic system of language, right? So the way we use language at this particular moment in time. And when you study language synchronically, you will see that, for instance, the vocabulary of particular language will be limited, right? It will be set. So you will say, okay, in this moment in time, we had all of these words, and this is what they meant. But if you look at the same language diachronically, as it goes like through time, you will see that its vocabulary is endless. It's limitless, because we constantly come up with new words, and also new structures and new ways to say things. So if you wanted to sit down and write down all of the words in a language, you will never finish, because as you write down a new word, another word appears, right? So language never ever stops changing. And this is what is tricky about language. And this is what is tricky about machine translation. And also, this is why machine translation will never steal your jobs. Because the second a new machine translation engine has stopped training, Trump tweeted something new, and there is a new word existing that that engine doesn't know about. So the future of machine translation is that we need an engine that will be continuously retrained on the new data that you provide. But we need you to provide it, because we need good quality, human-edited, human-translated language, human-edited data to train our engine. So I came up with something called workflow of the future. It's very ambitious, but I like this term. So right now, the way our work processes the way we do our work processes right now is kind of linear, right? This is our normal work process from like an engineering point of view. We get a new project, we pre-translate it, insert matches from the translation memory. The stuff that wasn't translated, we maybe machine translated, we send it to the translator, we get the work, and then we update the TM. So the engine just stays the same. And we have this little circle, right, of connected to the translation memory, so it's always updated. But I think that it kind of stops really saving you money at some point. It's like you will never get more than 20%, 100% matches from the TM, right? So it just becomes a management tool, so you don't forget how you translated the sentence in the previous project. But it doesn't really help the translator anymore. I propose that we should connect that into one big circle. It looks like this. So every time we receive human-edited language, we update the TM, and then we immediately retrain our machine translation engine because we just got new data. And then when we get a new project, we take that engine and we tune it according to that translator and that project. And then we machine translate the new source that we just got and set it for post-editing again. And the more times we do the circle, the better the machine translation becomes. And so I think a big solution that we need is we need to have some sort of a translation memory marketplace where we can trade our data with each other. And basically in the center of it is this machine translation engine that never stops being retrained because we are constantly feeding it some new data. But then at the same time, it never stops machine translating new stuff that just came in, right? And so what it means from the engineering point of view, I've been doing localization engineering for a year now. I think I know way more about it than I ever wanted to. And I can tell you right now that this idea that I'm proposing is kind of a Web 3.0 idea, right? So we're like all trying to move internet to this Web 3.0 era. And Web 3.0 means that everything is kind of, all of our data is stored in a distributed way, right? So there is no monopoly. There is no one central point that has all of the data and all of the money. We all own our own data. We decide what to do with it. We decide whether we want to sell it or not. Right now, we are in the Web 2.0 era, presumably. And Web 2.0 means that everything is web-based, right? As a millennial, I don't really use any applications. I do everything in a browser unless it's for work because translation doesn't work like that yet. Everything is, there is interoperability between apps online. So there are a lot of APIs that send information back and forth. That's not really happening in translation yet. All current Web 2.0 solutions that we have are for management, but nobody is really thinking about how we use data, nobody is really thinking about the translation data. The big problem so the point I'm trying to make is that translation hasn't even entered Web 2.0 fully to like go further to Web 3.0. And the really big problem that that I see right now is, for instance, the industry format. The industry formats, XLeaf and TMX, I love working with them. They're very informative, but they don't work anymore for the future and our current needs even. So even right now, the clients have such huge translation memories. They have so much data stored because they've been doing this for 5 years, for instance, and it's like a huge client. I can't even read their TMX files because they are so large. And the problem with TMX or XML formats is that in order to read even like one sentence from that file, I need to read the file completely. And so, because otherwise the computer will not understand the structure of the file. And so sometimes my PC can't even store that file in the memory because it's so large. So we're entering like the age of big data in translation. And we need a new solution to work with this big data because TMX doesn't cut it anymore. XLeaf, similarly, was created so you can send files back and forth. But so it was created to be confined into one file. But in Web 2.0, we should be sending strings back and forth. So we should be storing it in a way that we can pull up a string and send it to some web service. But that is impossible with XLeaf right now. I personally think we should be using JSON instead of XLeaf, but that is something that is a very engineering thing. The last one is machine translation is not ready for production yet because all of the times that in production our clients try to use machine translation, especially Google Translate, it always breaks the internal tags and the formatting. It's impossible to back convert in the end because machine translation doesn't, like translator can see that it's an internal tag and you shouldn't edit it, but machine translation doesn't care. It thinks that it's a word. And so it breaks, so when it tries to build some syntactic structure, it breaks, it thinks that the tag is a word, and so it breaks machine translation, and it breaks the tag. So we haven't even taken into account that maybe machine translation doesn't work for the way that we do translations right now. And that should be worked on as well. What it means for the translators, this is my favorite part. This is maybe when we implement this, this will give you more freedom, right? Maybe you can choose now not to give your data away to the vendor. Maybe you can choose to keep it. Maybe you will make less money with that vendor, but then you can keep your data. Maybe you can sell it to some vendor that gives you more money. Maybe you can keep it and tune some engine to your style. Maybe you can buy other translators' data because you want to have more 100% matches, right? The last point is really cool. It's something that is being developed right now. You can rent out your data. If somebody wants to train their own machine translation engine, but they don't have enough data, you can encrypt your translations and you can rent it out in a way that only the actual algorithm will see the words, but the client will not see your words. The client will only see the output of the engine. So you can actually keep your data personal, but you can rent it out so it can be used as training data for different engines, right? And so you can do it several times for different people. And what it means for the content, it really kind of bugs me right now that a lot of useless content is being translated. And I say useless because it's useless to me, right? So when some huge corporation, they need some manual to be translated or their website into 20 languages, and they give you a lot of money, so because that's what they do, they are a corporation. Their website won't probably be even like seen by many users because it's kind of like a formality. Nobody really cares what their website says. So it means that a lot of useless data is being financed for translation, but a lot of useful data, such as Wikipedia articles, like educational things, online courses, it's not being translated because it's open source, and so usually it's usually translated by volunteers or not at all. And so a lot of those things are not accessible in any language other than English. And so I'm hoping that maybe when we have this data trading system, maybe the demand will kind of drive what is being translated instead of the clients, right? So for instance, maybe somebody wants to machine translate online courses and they don't have data to train their engine on. But you as a translator, at some point, just translated an online course for yourself for free and you have the data. Well, now you can sell it and then now you can actually make some money on it. So that person that wants to translate online courses can have better machine translation and save money and pay almost like no money for their machine translation. And I want to finish on this point that I've been thinking about. I think right now translation is a customer-centric business because the customer has the money. And as a millennial, when I hear this, I kind of imagine this, the time when we thought that the Earth was in the center of the universe and everything else rotated around the Earth. So it's kind of an outdated idea for me. I think we should be working towards redefining the goal of our business. We should be shifting our incentives. We should come up with a system where having a lot of clients is not necessary to have a lot of money. It's necessary to translate well and to translate a lot to have a lot of money. And the consequence of this is maybe we should come up with a system where we have to translate as much stuff as possible to make more money, right? Maybe we should be thinking about, okay, let's not create an algorithm that will replace translators, but let's come up with a system where we can translate as much content into as many languages as possible and make all of this accessible to as many people as possible, not leave it centralized in like one English language. And maybe that will somehow bring the value of the whole market up. So that is all for me. That's enough of crazy ideas for today. I want to know what you think about all of this. If you are a developer, are you curious about the data science part? If you are a translator, maybe you are now a little bit more hopeful about the future of your profession. Maybe you're a business person and this made you very angry and skeptical. You can email me at Oksana@metamova.com, or if you want to know about my company's values and what we do and why, you can go to metamova.com and find out more about us. And thank you. Any questions? Do we have time for questions?
Hi, that was a really, really thought-provoking talk.
Thank you.
I really liked it a lot.
That's what was intended.
Cheers. My question is about, so I've been working with some, to a certain extent, with the results of the neural machine translation, and I find it really, really nice. It's really easy to post-edit for the language pair of English to Ukrainian. It's really, really, well, the improvement with the compared to the statistical machine translation is dramatic. My question is, once we're out of the topic that is related to the data set that was used to train that neural network, the results, the quality of the results drops. Because, for example, a style can be different, terminology can be different, etc.
Exactly.
How does that mix in the data sets that you've mentioned initially, that constructing that one massive silo? How can we counter that, and to what extent do we need to tune that neural language model? Because if we tune it too much, we'll end up with that same small data set that will be probably no good for actually training the machine.
What do you mean? No, if we put all of our, so we can, if our database in which we are training, it's kind of separated by field, right? So we have the technical field, whatever. We can add that to our neural network, and we can even say, okay, this is going to be a technical text, so you have to focus on the technical. Or maybe if we add, I actually don't know this because we haven't done this yet, because Google trains on general text, and Google is the best MT that we have. We have never taken all of different fields and trained one huge neural network. Maybe it will be smart enough to recognize that this is a technical text and produce the words that you need. You know what I mean? So maybe it's not even going to be a problem.
Even within the technical field, there are several. Well, there's a variety of topics. Well,
yes.
My experience comes from Microsoft, because I translate from Microsoft, and even among their products, there is a style difference. And once we switch the usage of that engine that was trained on one product to another product, I have to do much more post-editing.
Exactly. So you can tune that particular. So you can retune the engine for that particular purpose, and so it will know that, okay, I need to use these words more.
And that reduces our data set.
No, because so we take an already trained engine that's already trained on a huge data set, and then we only add the smaller data set at the end. And so we already have all this information about language in general. We are just kind of pushing this engine towards this smaller data set. So you will still, the bigger data set information will be preserved. You're just going to show, okay, I need the output that is more similar to this particular translation memory.
Okay, guess we're gonna have to have a look.
Yes, you should. You should.
I just say, just to confirm what you just said, this is exactly the way we work at SDL. So at the moment, with our own MT engines, Big Global and ETS, that works the same way. So the different language officers will choose the domain, particular domain. They have their main MT engines. Sorry, I'm just talking about the question you just answered, not everything else you were talking about. Yeah. So they have their own MT engines that are trained in general, and then they choose a specific domain they're working in, which contains data models that are specific to travel industry or to tech or marketing or whatever, to make sure the results are specific to that. So that's exactly the way we do it today. So yeah, so that would work. What you were just saying would work. Yeah.
Sure.
Just a short one. So when if we decide to sell our translation memory, if there's a market for translation memories,
yes,
there will have to be some sort of quality assurance service that makes sure that there's no crap in that massive silo.
So there are two ways. One is you have to earn reputation. So if somebody bought your data and confirmed that it's good, then your profile becomes better. The other one is translation consensus, which is something that I'm working on right now and something that I will probably present at some other event because it's not ready. But yes, we can have several people say, okay, this is a good translation, and so it's good quality.
So could I just add to something else there? So a couple of years ago, I saw a company called TMXO in China, who built a model, exactly the one you're talking about, of having a TM marketplace and selling the translation to different translators. And I went to visit them with a colleague of mine because they were using the APIs for students. And we had the same question: how do you control the quality of it over there? And they were adamant that they checked every single thing that went there. But when I go back and talk to them these days, the problem they've had is that translators Some translators were just taking Google MT, finding a way of getting the MT without paying for it, machine translating as much as they possibly could, and then submitting it as TMs.
I mean, I've been thinking about this for years now, so I've thought about that problem as well. And as I said, there are ways to ensure the quality. I mean, I'm not going to get into this because it's going to be like a 2-hour conversation. But yeah, I already told consensus. We can choose random people, make sure and ask them, is this a good translation, or we can actually work on reputation. But if you want to work on reputation, then it's going to be like a centralized platform, which is I think is also good.
So could I just add one other thing then? Sure. A positive thing is that there.
Please.
Yeah, sorry, no, I liked it. It was a very good presentation. Thank you. There is a company at the moment who's using blockchain to solve this exact problem that you're talking about. So the idea is that translators can take on work through the blockchain, so they become approved translators, and everything that they translate, if the company agrees, after it's been edited and approved by somebody else through the blockchain, can submit that approved translation for use into the continual training of a machine translation engine that is also managed by doing it through the blockchain in an approval process. And they're trying to build a whole ecosystem, and they're intending to put out their initial coin offer next month, I think.
I don't trust ICOs, but okay, I think that's too early.
To do just that.
Yes,
yeah.
But definitely. So the idea, the final component of all this is blockchain. But yeah. I don't talk about blockchain anymore. I don't want to because I want to be respected. Yeah. I do. I've been in the blockchain industry for a long time now. And yes, definitely. If you want something distributed and decentralized, and if you are talking about the marketplace, it needs a blockchain. Like it needs a coin, and it needs some way to make sure. So if you put translators consensus on top of blockchain, that will definitely work in terms of ensuring quality objectively. Yeah. So, any other questions? Okay, there's a question right here.
Yes, thank you for the presentation. I have the following question. As far as I understand, the key task is to increase the amount of data to improve the training of engines. But actually, the dependence is linear. I mean, if you put in a million segments or 10 million segments, then 10 million wouldn't mean 10 times better quality. I mean, the graph isn't like that. There is some minimal sufficient amount of segments that you need to ensure good quality. And of course, you can somehow, like Microsoft trains agents 100,000 segments and up. And then for some specific client, they would ensure decent quality. And 100,000 segments, that doesn't look like a lot. That's a big corporate, but still, you don't have to work too hard to actually gather this amount of data. So I don't really understand why is it important to increase the amount of segments a lot. Maybe I don't have the exact idea, but actually the engine can be trained even on a relatively small amount of data to ensure good quality.
So the question was, so you don't need that much data to make good machine translation, because there is a limit at which it stops growing so fast and becomes kind of linear. Well, my point is that, but language changes, like every language changes. So the idea is we need new words. We need to add new words and new sentences into our engine. So it's not about we need to add a million sentences for this one field or for this one client immediately. We just need to make sure that the engine is updated according to our latest reality. That's one thing. And the second thing is that, well, Microsoft, because they have so many products, they have a lot of data, but they are not going to share it. And so when you are a company that has a website or an app, and you don't have enough money to translate it into all languages, and you want to machine translate it, where are you getting that data? So we need to get data outside of those companies like Google and Microsoft. And we need data for all of the fields, because Microsoft has a lot of data for the technical field. Do they have something for legal? I'm not sure. I'm not sure it works as well. The EU has a lot of legal information, but I mean, it is open source, but anyway. But they only have it for European languages. What about smaller languages? What about rare language pairs? That's also important.
Спасибо большое.
Thank you a lot.
Okay. No more questions? Good. I'm very tired. Thank you for attention.